All right, gang, here we are talking about the law of conservation of matter slash mass. You can see it both different ways if you're looking online, but this will lead us into everyone's favorite, personal favorite of mine, balancing equations. First, let's talk about the law of conservation of mass and what it is. Matter cannot be created or destroyed during chemical or physical changes. So during a chemical reaction, notice this is highlighted. You'll want to know this for the test. The total mass of the reactants, so what you start with, must equal the mass of the products. So, in this reaction, if I start with 32 grams of sulfur and 56 grams of iron, then that means I have to have 88 grams because 56 plus 32 is 88. That the mass of all of the reactants must equal the mass of all of the products. So here's kind of a visual representation of the atomic level. So here we have CH4, we have 2 oxygen molecules, carbon dioxide, and 2 water molecules. And you can see I start with 1 carbon, I end with 1 carbon. I start with 4 little oxygen atoms and I end with 4 little oxygen atoms. I start with 4 red oxygen atoms and I end with 4 red oxygen atoms. What I start with is the same as what I end with. They're not the same thing. Right? CH4 is not CO2, oxygen is not water, but it's made of the same atoms. Now, in order to balance equations to get to what we're going to be able to do, you need to be able to look at a formula and be able to determine how many atoms there are. So, for example, we look at these 4 aluminum hydroxide. You need to be able to look at this formula and know that there is 1 aluminum. This 3 outside parentheses is distributed, so I have 3 oxygens and 3 hydrogens. Go ahead and pause the video and see if you can do the remaining 3. Okay, let's look at the answers. 1 potassium, 1 nitrogen, 3 oxygens. Here again, that 2 is distributed, so that's how I get 8 hydrogens, because 4 times 2 is 8. 1 sulfur, 4 oxygens. And the last one. Notice that the carbon there's 1 here and 1 here. That's how I get to 2 because they're added together. That little box will go away. That's how I get to 7 hydrogens as well. I have 4 and 3, so I add them together. I'm not multiplying. It's not the same as a number outside parentheses. I'm just adding them together. So how do we balance equations? So here's an equation. It's important to note what the difference is because there's 2 types of numbers here. There are subscripts, which tell us the number of atoms in a compound, and then there are coefficients, which tell us the number of compounds we have. And this leads to a fundamental difference between these 2 numbers. We use subscripts to balance charges within a compound, right, in writing formulas. But coefficients help us to balance the atoms in the equations. And it's only the coefficients that we can use to balance an equation. Only use coefficients. You change the subscripts, you're changing the reaction completely. You're changing the substance completely. So, to give you a visual representation, again, we've seen this already in a couple, but that's what this little 2, or let's look at the methane, the CH4, this little 4, it tells us how they're all bonded together. This O2, I have 2 oxygen atoms bonded together, but this big 2 tells me how many of these units I have. And again, what's important here is that the atoms that I start with are equal to the atoms that I end with. This is what we mean when we say the equation is balanced. Now, there are some tricks to balancing. For example, if you have a polyatomic ion on both sides, sides being reactants and products, so like NO3, NO3, instead of counting nitrogen and oxygen as separate elements and trying to do that, just consider this a unit. It's NO3, and you have one NO3 right here, and you have two NO3s right here. And then the last tip is if there is an element that is split into more than one molecule on a side, do it at the end. So an example here is a combustion reaction. So here I have the element oxygen, and you can see that it is split between with the carbon and with the water. And so this would be an example of balance the carbon, balance the hydrogen, and then balance the oxygen for last. And then for combustion reactions, this is a very unique situation that sometimes if you end up with an odd number of oxygen on the product side, you just need to double everything. It's pretty rare. We'll see an example like this in class, okay? So go ahead. Here are two examples. Let's see if you can balance these. Okay, let's look at the answers. You should have a coefficient of 2 in front of the HNO3, and then the rest, you would write 1s. Now, typically we don't write 1 as a coefficient, but I'm just putting these there so that you see that we have them. On certain quizzes that we will see online, sometimes you have to put the 1 there so that the computer recognizes that you're putting in an answer. But typically we would just leave it like this. This would be kind of our final answer. And if we look at the last example, this is what we would have for an answer. And again, if we were doing this on the computer, we would need to input the 1s right there to complete our answer. And that's it.